All right, here is your first video for 2.1, increasing, decreasing, and piecewise functions. So a lot of this I'm going to save for class with you guys, but we'll go over this increasing, decreasing part. So whenever you're looking at if a function is increasing or decreasing, always start from the leftmost part of your graph, so the most negative, and travel along your x-axis to the positive. So you can see on this first graph right here, this function is increasing, 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 increasing. He hits his highest point, and then he's going to start decreasing from that maximum, and then he's going to start decreasing down. Looking at this second example, starting at the leftmost point, he's decreasing, hitting that lowest value, and then he's going to start increasing. And then on this last example, it's staying constant the entire time. So those are your three options, increasing, decreasing, or constant, and you always want to look from left to right. A relative max of a graph is going to be the highest point that you can actually label. So infinity will never be a relative maximum. So I'm just going to put under this the highest point, and relative minimum would be your lowest point. If we look at this graph over here, we have one relative maximum, and then we have two relative minimums. So it's really about that turning point. So this graph starts, he decreases, he hits a relative minimum, he starts to increase, we had a relative max, then he decreases again, hits that relative min, and then starts to increase again. So whenever we have one of those turning points, you're going to have a relative max or a relative min. So let's look at this first example here, and we're going to talk about where it's increasing, decreasing, constant, and then what its relative max and mins are. So when I'm looking at this graph right here, traveling left to right, from here down, that's decreasing. So I know that I'm going to have, and I'm only talking about the x values here, he's going to decrease from negative infinity all the way up to -1. When we talk about increasing, decreasing, or constant, you're never going to use brackets because it's not increasing or decreasing at -1. It's just where that shift happens, so just parentheses on everything. Then next, between -1 and 3, between the x values of -1 and 3, he's going to stay constant. So -1 to +3. Then the next portion, from the x value of 3 up to an x value of 5, he's increasing. And then it looks like from 5 forever and ever and ever and ever and ever, he's going to start to decrease again. So we're just going to go and 5 to positive infinity, he's decreasing. This has a relative maximum, so this point, that turning point from increasing to decreasing, at 5,2 is going to be a relative max. So we say he has a maximum value of 2 when x is 5. So the highest point he's going to hit is 2, besides talking about infinities there. The relative min, the lowest point this graph is going to go that we can actually touch. Well, there's kind of two of them. There are these two values. So I'm going to say his relative min is -2 when x is between -1 and 3. So you're just looking at those highest and lowest points. All right, I'm going to do this example number 2 with you, and then that might be all we talk about. So we have two nurses. They drive away from a hospital at right angles to each other. So we'll just go ahead and draw a picture here. Here's our two nurses driving away from each other at a right angle. Kiara's speed is 35 miles per hour. So 35 miles per hour driving away from that hospital. And then 40 miles per hour over here. And that's Nadia. And then we want to know the distance between the two cars. So the distance between the two is going to be this diagonal distance from those two vehicles. So we're just looking at the Pythagorean theorem. I'll let this be our a squared, or a value, sorry, our b value, and our c value. So we're going to take 35 squared plus 40 squared equals the distance between the two cars. We'll just call it c squared. When we do the Pythagorean theorem on this one, so we're going to get 40 squared. That's going to give us, or let's do our 35 squared first. So 1,225 plus 1,600 is equal to c squared. Add those two together, we get 2825 equals c squared. Square root that value, and they're going to be about 53.15. Well, that's really talking about the miles per hour, so we need to go ahead and put a variable on that when we talk about this as a function of time. So the distance in terms of time is going to be 53.15 times whatever the time is. In this case, hours. So every hour they're going to get 53 miles away from each other, roughly. The domain of this function, so we can't have, time is going to be our domain because time is our x value, so domain is our x values. In this case, that's going to be time. So when we think about how much time can go, we can't have negative time for them to travel away from each other, so your domain here is going to be anything bigger than or equal to 0. 0 would be when they're still at the hospital together, and then anytime after that. And if we want to put that in interval notation, 0 to infinity. And then the rest of this, we're going to go ahead and save and talk about in class. So bring the rest next time we see you.